In this video, we're going to be balancing some chemical equations, and the particular point that I want to emphasize in this lesson is how do I choose which elements to balance first, and more specifically, which elements to balance last. That's primarily what I'm going to be covering here, and we'll also go through some examples. But that's going to be really helpful in that it'll just make a problem a lot easier. You don't ever have to balance things in a certain order. As long as you get the same number of elements on both sides of the equation, you get the right answer. But balancing the chemical equations in a certain order is just going to help turn a really hard problem into a lot easier of a problem. So that's what we're going to practice today. Go ahead and pause the video and try to solve this problem. And if you don't feel too confident in balancing chemical equations, at least set up the problem. So count out which elements we have and how many of each we have, and come back after you at least do that. Preferably try to solve it though as well. All right, now that we're back, we are going to start setting this up. So here on the left side of the equation, I have hydrogen, oxygen, and carbon. And then on the right side, I'm going to have the same elements: hydrogen, oxygen, and carbon. Now we need to count how many of each element we have. So I see here that I have 2 hydrogens on the left side. I have 1 oxygen here plus 2 more right here. So I have 3 total oxygens. For carbons, I have 1 total carbon. On the right side of the equation, I have 7 carbons. I have 8 hydrogens. And I have 2 oxygens. I'm also going to draw this out because I think, especially as we first are learning about balancing chemical equations, it's really helpful to draw out what these compounds look like. So let's try doing that here. H2O is going to look like this. We're going to have oxygen bonded to 2 hydrogens. And then CO2 is going to look like this. We have carbon bonded to oxygen. I'm not drawing the extra electrons, but they're there. And then C7H8. This one's, let's think about what this one looks like. All right, for C7H8, I'm just going to write down C7H8 because what the compound looks like isn't going to make a whole lot of sense to most of us at this level of chemistry. But C7H8, there are 7 carbons and 8 hydrogens. It actually looks something like that, where we have carbons on each of these corners and hydrogens attached, but something like that. But I'm just going to write C7H8 for simplicity. And then I have O2. And O2 looks like this. I've got oxygen double bonded to another oxygen with our electrons, but I'm not drawing those right now. All right, so that's what we have right now as we start the problem. And we have everything counted. We see that nothing's balanced right now, and we need to figure out which is the first thing we should balance. And then what's the second thing I should balance? What's the third thing I should balance? And in a problem like this, you're going to notice that I have hydrogen bonded to oxygen here. And I have carbon bonded to oxygen here. And carbon bonded to hydrogen here. But over here, I have oxygen bonded to oxygen. Oxygen bonded to oxygen. So oxygen is not bonded to another different element. And the way this works, balancing chemical equations is kind of like doing a puzzle. And if you're strategic, then you're going to be a lot more successful. Since oxygen is not bonded to another element, when I change a number here, when I put a different number here, right here, it's not just changing it's only changing the oxygen. It's not changing anything else. So it's best to save this oxygen for last, because we don't want to save something for the end, and then change a number, and then it changes a different element that we didn't want it to change. So if an element is by itself, not bonded to another element, save that one for last, and it'll make your life way easier when you're doing this. So actually, let's that's a tip that I want to write down for us. So let's put that down here. All right, so it is easiest to balance an element's last if it is not bonded to another different element. And let's make sure we know that we're referring to oxygen in this example. So all right, so it is easiest to balance an element last if it is not bonded to another different element. All right, so in this example, oxygen is going to be balanced last. All right, so what should we balance first? Well, here we're going to notice that it's going to be just as easy to balance carbon or hydrogen. It really doesn't matter in this example. But I will tell you that carbon is typically one of the easier elements to balance first. Carbon and metals, both for the most part, are usually easier to balance before other elements. But really, I just look at the numbers and see, okay, it's easiest to put a number here to get 7 carbons. And so I would say carbon's the easiest one to balance first. So you can use that as a general guideline, balance carbon first if you can, but really the more important thing is what you're balancing last, and this is going to be an extremely helpful tip for us to follow. All right, so noticing that I have 7 carbons on this side and only 1 on this side, and there's no numbers written here next to the carbon, it's going to be pretty easy to balance this carbon. So let's go ahead and do that. If I put a 7 right here, then it is going to balance our carbons. I now have 7 carbons. But hold on, carbons, this 7 doesn't refer just to the carbons. It also refers to the oxygens. So carbons didn't change. It wasn't just carbons that changed when I put that 7 there. Oxygens also changed, so I need to recalculate oxygens as well. So by putting a 7 there, I still have 1 oxygen right here. 1. Plus, now I have 7 times 2. I have 14 more oxygens right here. So this is no longer a 7. It is now a... This is still a 7. But for oxygens, this is no longer 3, but we now have 15 oxygens. And let's draw that here so that we can count. I think a lot of us like to visually see what's going on. So I don't just have 1 CO2, I have 7 CO2s. All right, there we go. I now have 7 CO2s. 1, 2, 3, 4, 5, 6, 7. And when I count these, I see that I have 1, 2, 3, 4, 5, 6, 7 carbons now. And then I have 1 oxygen right over here, plus 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 oxygens. That matches up. All right, so it's helpful when I drawing this out, so that's what I'm doing for us here. All right, so we now see that carbons are balanced. But, and we're doing oxygen last, so that means we're going to do hydrogen next. All right, I notice I have 8 hydrogens on the right side. So what number do I need to insert here to change the number of hydrogens to 8 on the left side as well? Well, if I put a 4 here, then now I have 4 times 2 equals 8. But this 4 does not just change the number of hydrogens, it also changes the number of oxygens. So we need to figure out how many oxygens we have now. And so let's recalculate that. I still have 14 oxygens over here. 7 times 2 is 14. But over on this side, I have 4 times 1, I have 4 oxygens. So 4 plus 14, I now have 18 total oxygens. And some people ask, well, how did we go from 15 and putting a 4 there, now we have 18? Well, that math doesn't add up. Well, I think that is a very, very, very common point of confusion. People say, well, I had 15 before, now I'm going to add 4. No, don't do it that way. It's really confusing. I would strongly recommend not doing it that way. What I like to do is whenever I put a new number as a coefficient, forget what we had before. It does not matter at all whatsoever. All these other previous numbers don't matter at all. We're going to recalculate things and say, forget what we had before. We now are going to recalculate, and when we recalculate, we calculate 18. Let me show us how we have 18 oxygens, because again, kind of confusing for a lot of people. So instead of just having one H2O now, I have 2, 3, 4 H2Os. So again, when I count my oxygens now, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So that's how I get 18 oxygens. Okay. So hydrogen is balanced. Carbon is balanced. Now we got to focus on the oxygens. All right, so we got to think about where I can add a number in order to balance out the oxygens. And so oxygens, I'm going to add a number here. And what number do I need to add there? First of all, I know that I'm adding the number there because this right here has nothing to do with oxygens. It's C7H8. There's no oxygens involved there. So I know that the number is going to go here. And what number am I going to put there? So I need to ask myself, what times 2 equals 18? What times 2 equals 18? Well, I know that 9 times 2 equals 18, so I'm going to put a 9 there. And whenever I put that 9 there, I'm going to recalculate the number of oxygens. I now, instead of having 2 oxygens, I now have 18 oxygens. And then just since we've been doing that over on the left side, let's redraw that and visually show that we have 18 oxygens. So we're going to do 9 of these. 4, 5, 6, 7, 8, 9. All right, we now have, and if I count them, we now have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I have 18 oxygens. So 18 oxygens on both sides of the equation now. All right, when we double check our work now, we now see that 8, 8, 18, 18, 7, 7. Everything is balanced. We got that question right. All right, so now that we know what we're doing and we know which element to balance last, again, the entire point of that problem is I wanted us to see that it is easiest to balance an element last if it is not bonded to another different element. If you wanted to go back and reattempt that problem, you'll see that it's a lot harder to do this problem. In fact, we won't even have learned the method yet to do a problem like this if we don't balance oxygen last. So if you see an element by itself not bonded to another different element, balance that one last. We're going to do one more example here showing that strategy that we just went over. So let's do that here together. Pause the video now and go through this problem on your own. Once you finish solving this using that same method that we just went through, come back and you can see if you got the right answer. All right, I'm going to set this up for us. We've got C, H, and O, C, H, and O. I'm going to do this one a little bit faster. I notice that I have 3 carbons on the left side. I have 8 hydrogens on the left side. And I have 2 oxygens on the left side. On the right side, I have 1 carbon. I have 2 hydrogens. And I have 2 oxygens over here, plus 1 more over here. I have 3 oxygens. All right, I see that currently nothing is balanced. And oxygen is the only element that is located by itself, not bonded to another different element. So it is going to be by far the easiest one to balance last. So we're going to save oxygen to balance last here. I got to decide now which one to balance first. And just the rough strategy of carbon typically being an easier one to balance first, we're just going to go along with that and say that I'm going to try to balance carbon first. All right, I notice that there are 3 carbons on this side of the equation. So I need to figure out where I need to add a number in order to get 3 carbons on the right side of the equation. And since this is the only spot on the right side of the equation that has anything to do with carbon, I know that my number is going to go right here. And then I'm going to ask myself, each CO2 molecule has 1 carbon. So what times 1 equals 3? What times 1 equals 3? Well, 3 times 1 equals 3. So by putting a 3 here, we should recalculate everything on that side of the equation. I now have 3 carbons. And then 3 times 2, I have 6 oxygens plus that 1 more right here. So 6 plus 1, I have 7 oxygens now on that side of the equation. And hydrogen stayed the same. So carbon is now balanced. I'm now going to balance hydrogen next because we're saving that oxygen for last. So I have 8 hydrogens on the left side of the equation, but only 2 on the right side. So I need to add hydrogens to the right side of the equation by inserting a number right here. So what number should I insert right here? What times 2 equals 8? That's the question. What times 2 equals 8? Well, I know that 4 times 2 equals 8. So 4 times 2 equals 8. So I'll put a 4 there. I now have 8 hydrogens on this side. But wait, we got to recalculate everything on that side of the equation. So 4 times 2 equals 8 hydrogens, but I also have 3 times 2 is 6 plus 4 times 1. I now have, plus 4 times 1 is 4. So I have 10 total oxygens on the left side of the equation. Again, don't think about, well, I previously had 7. It doesn't matter how many you previously had. We're crossing it out and recalculating. We now have 10 total oxygens on the right side of the equation. All right, carbon is balanced. Hydrogen is balanced. And so I need to figure out where to add a number in order to balance the oxygen now. So let's do that now. All right, so here's where we're going to have to add our oxygen. I have 10 on this side. I need to add some oxygens over to this side of the equation. And this has nothing to do with oxygen. No oxygen's there. So where can I add what number can I add right here in order to get to 10 total oxygens on the left side of the equation as well? So if I'm rephrasing that question for us, what times 2 equals 10. What times 2 equals 10? Well, we probably know that 5 times 2 equals 10. And let's recalculate everything over here. Well, 5 times 2 equals 10. We still have 8 hydrogens, still have 3 carbons. We're good. All right, so we get our final answer of 1C3H8 plus 5O2 yields 3CO2 plus 4H2O. Got our right answer there. Now, some of you might say, well, Mr. Oxler, wait a second. I did this problem, and I think I did it right. I got, it looks balanced. I got 2C3H8 plus 10O2 gives us 6CO2 plus 8H2O. Got it written down there. So some people in my classes have gotten this as an answer. And you're completely right if you said this is balanced. It is balanced. But when we're looking for a balanced chemical equation, we're looking for something that's not only balanced, but also simplified. So notice how all of these numbers can be divided by 2. Since they can all be divided by 2, we're going to divide them all by 2 and simplify our answer to the simplest possible answer. So when we divide them all by 2, we're going to get 1, 5, 3, 2, which is the same answers that we got up here. So there's only one correct answer. If you have something that's not simplified, it's not going to be correct. All right, so even though this is balanced, it is not simplified. Your answer needs to be balanced and simplified. All right, so that's everything that I wanted to cover. That's 2 example problems from this concept of if we have an element by itself, then we want to save that one to balance last. So as long as we understand that and are doing okay with balancing these chemical equations, then I think we're okay to move on to the next video. The next video is going to be explaining what happens when I have when things don't seem like they're going to balance. What's a strategy that I can do when I get stuck? So we'll cover that next.